Dear students, in this lecture we will discuss about probability because we do statistical interpretation in quantum mechanics. So probability has a main role in quantum mechanics. To understand the probability, first we start with the case of discrete variables. Suppose there is a room containing 14 people and they have different ages. For example, one person has age of 14 and there is also another one person having age of 15 and three people have age 16, two people have age 22, two people have age 24 and five people have age of 25. Now in general form we can simply write n of j supposed to represent the number of people of age j. So simply we can write n of 14 equals 1, n of 15 equals 1, n of 16 equals 3, and similarly up to n of 25 equals 5. You can see there is a systematic histogram for all of the ages. Suppose you can see here is one box for 14 because we have only one person having age of 14. Similarly for 15, and you may see that there are five boxes for the age of 25 because we have five people having age of 25. And you can also see we have nothing like boxes for 17, 18, 19, 20. So simply n of 17, n of 17 is 0. So now total number of people in the room can be written in general form as n equals summation from j equals 0 to infinite n of j. Let's call this equation number 1.4, just following the book of the Griffith. Here are different questions and we need to understand how to solve them. Question number 1. If you selected one individual at a random from this group, what is the probability that this person's age would be 15? You know, in this group, there are 14 people and we know that only one person has age of 15. So it means one chance in 14 because there are 14 possible choices and all has to be occurred equally. Now, if we simply write P of j, and that is the probability of getting age j, then suppose getting of age 14, that simply equals 1 over 14 because there's only one guy, one person having age of 14, has age of 14, and there are overall 14 people in the room. So simply because one person has age 14, so I simply write 1 over 14. And similarly for age of 15, simply write 1 over 14 because there is only one person has age of 15. But you know, age of 16, you can see this histogram, there are three boxes, meaning that there are three persons having age of 16. So simply we will write 3 over 14. And in general now, we can write P of j equals n of j over n. N of j means how many persons having age of j divided by the total number of persons. So this is the way how we write this expression, and this one. Now, if someone asks us now that what is the probability of getting either 14 or 15? Okay, it means now we are going to select one person out of 14 people. Now, what is the probability that the person which we are going to select has age of 14 or 15? So it means now simply we will sum up of the individual probabilities of 14 and 15. And you know, individual probability of 14 equals 1 over 14 and individual probability of 15 equals 1 over 14. So simply we will sum up 1 over 14 plus 1 over 14 and we will get 1 over 7. So probability of getting either 14 or 15 is the sum of the individual probabilities. Now in particular, the sum of all the probabilities is 1. So now in general form, we can write summation j equals 0 up to infinite p of j equals 1. So this means whenever you select one person out of the 14%, there is always a probability that you will select anyone of having some age. And the person you select must have some age. This is the way how you can then express in general form by taking the summation of all of the ages of the persons. So summation j equals 0 up to infinite p of j equals 1. Suppose this is equation number 1.6. Now, question number 2. What is the most probable age? It means which age person supposed to be occur mostly comparatively the other ages person. So if you look at the histogram, you can see that there are 5 boxes on 25. So it means there are 5 people having age of 25. So 5 people share this age. It means there is most probability of occurring of 25 ages person. So because this is the most occurred age, so hence we will simply say 25 is the most probable age. Now, what is the next question? What is the median age? Please note that median means that the value of j such that the probability of getting a larger result is the same as the probability of getting a smaller result. This is the definition of median. So if you look at the histogram, then you can see here that 23, where 7 people are younger, 1, 2, 3, 4, 5, 6, 7, and 7 people are older, 1, 2, 3, 4, 5, 6, 7. So this is exactly the median age, 23. So the answer simply is 23. Now, next question, what is the average age? You can also say mean age. So this is quite simple question. You just need to add up all of the ages, like 14 plus 15 plus 3 into 16, because there are 3 persons having age of 16. So simply multiply 3 with 16 plus 2 into 22, because there are 2 persons having age of 22, and similarly for 24, and because there are 5 persons having age of 25, so multiply 5 with 25. And this is the way you will add up all of them. Divide by 14, because there are total 14 people in the room. So simply you get 294 divided by 14 equals 21. So 21 is the average age. Now in general, how you can write the average value of age, the average value of, for example, j. So j average, you can please look at the symbol we are going to use now for the average. J equals summation j n of j over n equals summation j from 0 up to infinite j into p of j. If you just focus on this, you can see that p of j, as we have discussed in question number 1, that is p of j equals n of j over n. That is how simply we replace n of j over n by p of j. And there is j, that is simply the any number of age that will simply multiply with the probability of getting any number of age. So this is how you using the general form for the average value of j. In question number 4, we simply answer what is the average of age, and in general form we simply write summation j equals 0 up to infinite j of p of j. But in question 5, we should answer for the average of the squares of the ages. So simply take the average of the square of the ages. For that, simply take the square of the age. 14 square equals this, 196. And the probability of getting 14 is 1 over 14. And for the 15 square equal 225. And also for the probability of getting the 15 is 1 over 14. For the 16, that is the square of the 16 equals 256, and the probability of the 16 was 3 over 14. And this is the way how you can write for all of the ages. Now, because we should answer for the average of the square of the ages, so simply take the average of the square of the age equals summation j equals 0 to infinite j square p of j. As we discussed in question 4, we simply have j here in question for the answer of the question 4, but in question 5, because we were asked for the average of the square of the ages, so simply the expression gets square term, and that is j square average equals this expression. And now you can write this in more general form by simply saying that average value of some function of j is given by f of j average equals summation j0 to infinite f of j p of j. Okay, this is how you can solve different questions whenever you have a discrete variables in some cases.